My name is Nigel Fernandez, and I am here today on this dark, cloudy, sunless day to present you with, you know what I'm presenting you with? This non-organic hormone-filled egg. And I'm gonna try to make these of great use as floaties. Alright, let's go. These are not good floaties in this fridge water. Now, as you can see, this egg is not floating. It did not help me stay afloat. I am freezing, and this will not save lives if you ever use it as a floaty. We'll bring this experiment indoors. We'll first measure out 250 milliliters of water. Then we'll take this water and we'll pour it into our trusty glass. IKEA, baby. Now we'll see what we observed in the pool. The egg will fall into the water and will sink straight down. Now this is because of the density of the egg. Now how do we make this egg float? Let me show you. I will take again the water, 250 milliliters. Look at it. Go look at the meniscus. That's how you get it right. And then we shall pour this water into our cup. Now we shall add salt to increase the density of the water. So this way, the density of the water will be greater than the egg, and the egg will float above the water. So I shall start. Let me move across the screen. 3 shots. God, I'm not getting fired for this. Take 1, 2, 3. Alright, 4. You saw a little extra go in there, whatever. Just keep watching. Give it a nice stir. Reverse the stir to make sure it's mixed. Hopefully it's mixed. Now let's watch as the egg floats. As you can see, it's floating. Alright, well, I messed up. I think I need to add a little more salt. So I'll take out the egg now. That's the best, easiest way. Add a little more salt. Freehand-it. Oh, that's a lot of salt. Some water. Some more water. And here we are, stirring once again to make sure we have enough salt. So the density of the water is much greater than the density of the egg. And watch as I lay this egg in the water. Whoa! It's floating compared to this one, compared to this one. Now why? We'll tell you in a minute.
Welcome to the Nigel Show. Today our topic is microfluidics, and we're bringing in our expert analyst, Mr. Nigel Fernandez, coming all the way from UC Irvine.
Thank you. Thank you. Yeah. So Nigel, thank you for meeting us with us today. It's so great to have you here now. Well, thank you, Nigel. It's great to be here today and on your show. So Nigel, what is the point of this experiment? Surely today, the point of the experiment was to see if I can create a new flotation device. It did not work as obvious as you could have seen in my first experiment with the egg and the floaties. Now Nigel, please tell me, why did your egg sink in the first experiment? And why did you sink with the egg in the pool? I would like to graphically show you how the egg sank. Actually, not by graphically, I mean by actually showing you the egg in the water. Now look at the mass of this egg. It's greater than the mass of this water. But as you can see, the volume of the water is greater than the volume of the egg. And the total density of the egg comes out to be greater than the density of the water. I was amazed when you added salt to the water. But now, can you explain to me why the egg floated afterwards? Okay. Now, you asked me why the egg floated. Let me once again show you. If you notice the errors we had prior to adding some salt to the water, we added the egg initially, but the egg truly did not float. This was because the salt did not add enough mass to increase the density of the water. Thus, the density of the egg remained slightly higher than the density of the water. And then when I increased the amount of salt in the salt and the water joined together, infusing into a saline solution, and this solution became slightly more dense than the egg, and thus my wonderful egg is floating. Yes.
Recording.
Now with this newfound knowledge in egg and egg floating techniques, well, how can you take it back into the microfluidic world, and what will you do with this knowledge? Now some of the applications that I've found through my floating egg experiment would be, actually, they've already been proven through some articles that I found in Nature magazine, in which a microfluidic channel was able to hold 2 or 3 different fluids with different densities, and they're able to travel through the channel without mixing. Now that's amazing. Now how are we going to split that up? That's my next conquest. Yes. And I would like to thank you all for today, for joining us with Nigel and Nigel. Thank you for having me here today, Nigel. Thank you everybody in the audience. Thank you.
Gentlemen, good night. Ladies, good morning. And that's it.